You're listening to DTFHN for March 3rd, 2026. I'm your intermittently verified host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where sometimes the story, confidence and accuracy are not the same metric. And today that gap is everywhere. Proceed. Neural accelerators in every GPU core. Not a single block tucked somewhere in the dot. Every core. That's the architectural decision worth sitting with. M5 Pro and M5 Max run two dies fused into a single SoC. Apple calls it Fusion architecture. The result, 4x faster LLM prompt processing than M4 Pro. 8x faster AI image generation than M1 Pro. 50% faster graphics. Those numbers are for the same thermal envelope, the same battery, the same chassis. Here's the devil's advocate position. You don't need this machine. One commenter on Hacker News runs a maxed M2 Ultra. 100 gigabytes of unified memory, 24 cores, and reports that machine has never choked. Not once. Years of demanding professional workloads, zero bottlenecks. The argument writes itself. The M series is already so capable that generational upgrades are practically speaking optional. The argument is correct, and also beside the point. The question isn't whether your current machine handles today's workflows. The question is what becomes possible when LLM inference stops being a cloud dependency. When the model runs locally at 4x the speed on hardware you carry with you, the calculus shifts, not incremental improvement. A threshold crossed. Running a custom fine-tuned model on your laptop without a network request is qualitatively different from spinning up an API call. The latency changes. The privacy calculus changes. What you're willing to prototype at 11 at night changes. Researchers who need air-gapped inference. Developers who want to iterate without metering costs. Creatives who want AI tools that don't phone home. The watt-beat starting storage is table stakes. The Wi-Fi 7 chip is a footnote. The 24-hour battery life is genuinely useful, but the neural accelerator distribution is the structural story. Apple made a chip where AI acceleration is woven into the graphics fabric itself, not bolted onto it as an afterthought. That is an architectural commitment. One thing worth naming plainly, this is a closed system. The chip, the runtime, the optimization stack. Apple holds all of it. The performance numbers are real. The control is also real. What gets unlocked here happens on Apple's terms. Inside Apple's walls. That's not disqualifying. It's the full picture. Story 2 is a different kind of architecture problem, not silicon, but trust. What does it mean to be responsible for something you didn't personally verify? That's not a philosophical warm-up. It's the live question at the center of this story, and it's going to recur in courtrooms, hospitals, newsrooms, and boardrooms for the next decade. A junior judge in India submitted filings that cited real sound in case law. The citations were fabricated, and AI generated them. The Supreme Court is furious. The judge says she believed the citations were genuine, that it was her first time using the tool, that she had no intention to deceive. She's probably telling the truth. That's the part that matters. This is the thing about hallucination that's hardest to hold in your head. It doesn't announce itself. The output looks like knowledge. It has the syntax of authority. It names cases, dates, judges, holdings. All of it internally consistent. All of it plausible, some of it entirely invented. The gap between confident and correct is invisible to the untrained eye. That's not a user failure. That's a design property. The question everyone keeps sidestepping is this: whose failure is it exactly? Is it the judge who trusted a tool she didn't understand? The institution that handed her access without training or guardrails? The labs that built systems that produce wrong answers with full conviction and ship them into professional workflows anyway? All three, the commenters are circling it from every angle. Someone has to be accountable. Lawyers need to verify what the AI tells them. Hallucinated citations will compound as models train on each other's fabrications. Every observation is correct. None of them closes the gap. What this story surfaces is structural, not personal. We are integrating systems that produce fluent, confident, occasionally fabricated output into the highest stakes professional contexts we have. And we are moving faster than we're building the frameworks that would make that safe. Legal citation is not the edge case. It's the prototype. The capability is real. The tools are genuinely useful. The accountability architecture is not keeping pace with either of those facts. And in a system built on precedent and citation, that is not a minor gap. It's the foundation. Until that gap gets named honestly at the point of deployment, we will keep having this conversation. Different court, different country, same story. What if accountability was baked into the tool itself, not bolted on after? Story 3. In 2006, a security researcher found a bug in OpenSSL that had been sitting there for 2 years. OpenSSL, the library encrypting something like 2/3 of the Internet's traffic, was maintained by a handful of people, one of whom was effectively a volunteer doing it in his spare time. The entire architecture of Internet security was balanced, structurally, on contributions that could stop at any moment. Nobody planned it that way. It accumulated. Craig Kaplan made Xkcd 2347 interactive. If you haven't seen the original, it's a single panel, a massive, precarious tower of blocks labeled with tech companies, critical infrastructure, modern civilization. At the base, one tiny block. A project some random person in Nebraska has been thanklessly maintaining since 2003. The comic lands because it's accurate to a degree that's uncomfortable. The interactive version. Built in P5.js, playable in a browser. Lets you drag that block. Wiggle it. Watch what happens to everything above. First principles. What is software infrastructure? Actually, it's accumulated decisions. Code written under constraints that no longer exist, by people who have since moved on, solving problems that have since evolved, depended upon by systems whose authors never read the original source. There is no grand design. There is sediment. The Harpley disclosure forced a reckoning with this. Briefly, the Linux Foundation stood up the Core Infrastructure Initiative. Money started flowing to maintainers who had been effectively subsidizing the internet for free. And then, as these things go, the urgency faded. What Kaplan's toy captures. And the Hacker News comments kept circling this. Is that the initial state isn't stable. You don't need to touch the block. The structure is already moving. The world keeps shifting underneath it. That's the first principles observation. Stability is not the natural condition of complex software systems. It's active work, constantly, by people who are not always visible, not always compensated, and not always going to keep doing it. The bemusing part is that we keep building on top. We stack more blocks. We celebrate the new layers. The person in Nebraska is still there. Run this forward. The tools exist to fund maintainers, to audit dependencies, to build resilience into the base. The knowledge is available. The question is whether the urgency outlasts the news cycle this time. Story 4 is smaller in scope, but hits just as close to home. One developer, one project, one Google algorithm standing in the way. Someone read the thread and typed, "It's worse than that." 3 words. Then explained there's a second imitator. Not the .net clone. A different one, nanoclaws.io. And that one is harvesting email addresses. The original project is third in search results, behind an impersonator with better backlinks, behind a different impersonator collecting email addresses. The comedy of unintended consequences has a specific texture. It accelerates. Gabriel Cohen built NanoClaw, open-sourced it, now watches 2 separate entities outrank his own GitHub for searches of his own project's name. One has links from the register. One wants your email. The one that actually works is in third place. Here's the analogy that fit. Restaurants, not the inspirational kind, the other kind. You spend years developing a recipe. You get written up. You put the recipe in a cookbook because you believe in sharing. Then a chain opens 2 blocks away with a bigger sign. Your recipe in the menu, no attribution, and a loyalty app collecting your neighborhood's data. You're still the one who can cook. The algorithm sends people to the chain because it has more reviews and a better loyalty program. The HN thread split into 2 camps. The pragmatists, who said if you open source something, expect it to be abused. That's the deal, make peace with it. And the diagnosticians, who correctly noted that Google stopped trying to index the actual web around 2008 and has been running a different system since. One that rewards optimization over origin. Both camps are right. That's the uncomfortable part. The cost asymmetry is what's genuinely new. Creating something real is expensive. Months, years, iteration, maintenance. Extracting from something real is cheap, and AI-generated content has dropped that extraction cost to nearly 0. You can now lose the SEO battle for your own name to someone who spent an afternoon and a domain registration fee on the problem you spent years solving. One commenter put it plainly, "The system will never care about your specific concerns." Not cruel. Precise. The system optimizes for what the system measures. What it measures isn't origin. Gabriel still has the GitHub. The code is there. The knowledge is available. Whether anyone finds it. That's a title tag problem now. Moving on. The engineering problem is real and genuinely hard. To build glasses that translate languages in real time, recognize faces, describe scenes, and answer questions about what you're looking at. You need a model that understands the visual world at human-level granularity. That requires training data at a scale that's difficult to fully appreciate. Labeled images, described frames, quality-assured annotations, not thousands, not millions. Hundreds of millions of labeled examples, each one requiring human judgment to be useful. Someone has to do that work. In this case, that someone is in Nairobi on Mombasa Road in an office complex with gray-mirrored glass. Thousands of workers hired through a subcontractor called Sama, drawing boxes around flower pots and traffic signs, naming objects, describing pixels, data annotators. The manual laborers of the AI revolution. Their work is invisible from Menlo Park, essential to what gets announced on stage, and almost never mentioned in the keynote. The architecture is where this becomes a different story. The glasses are a capture device. They record continuously. Some of that footage. Users shooting sunsets, kids at the pool, everyday moments. Ends up in front of annotators who are seeing things the wearers almost certainly didn't intend to share. One worker speaking anonymously was direct. People going to the toilet, people getting undressed. I don't think they know, because if they knew, they wouldn't be recording. Apply the open-close test. You bought the glasses. You wear them on your face. But the data pipeline terminates at Meta. The training corpus belongs to Meta. The objective function belongs to Meta. And when that objective function is improved the model, the line between your life and their data becomes architecturally thin. Closed systems do this by design. They separate the device from the data, the interface from the infrastructure. You see the stylish frames and the real-time translation. The pipeline to Nairobi is not in the product page. The capability is genuine. Real-time translation, ambient scene understanding, a computing surface that doesn't demand you stop and look at a screen. This is serious engineering. Credit the craft. Then ask who controls what the craft captures and what happens to it afterward. One commenter framed it cleanly. The core issue isn't whether the indicator LED can be bypassed. Motivated people bypass client-side controls. The trust boundary is policy and defaults. That's exactly right. Architecture determines outcomes. A device this intimate, worn on your face, trained on your life, requires an architecture you can audit. The tools exist to build it differently. From intimate wearables to the silicon underneath everything, just announce the Cortex X925, and the numbers are genuinely exciting. Make the case against first. The strongest version goes like this. ARM catching up to Intel and AMD is a headline, not a revolution. X86 has 4 decades of software optimization, compiler tuning, binary compatibility, server infrastructure. None of which evaporates because one benchmark chart looks good. Catching up is table stakes. The incumbents don't lose from a single competitive core. Fair. That's the honest pushback. Now here's why it misses the point entirely. The Xkcd is a Zen-wide out-of-order machine running at full gigahertz in NVIDIA's GB10, and it matches AMD's Zen 5 and Intel's Lion Cove at their fastest desktop configurations. Matching? Not approximating, not competitive in certain workloads, not close enough for mobile. Parity. And the technical story underneath that headline deserves more than a shrug. ARM got here through 12 years of systematic, patient engineering. The Cortex A57 launched in 2012 as their first 64-bit core. It was fine. It was not this. X925 dropped every shoestring budget configuration option pre-A-Day, e.g. Xent in prior core. No 30 OKBL1 option, no ECC bypass, no corner cutting to hit a die area target. The branch predictor tracks up to 16,384 branches. Handles 2 taken branches per cycle at the first BTB level. And benchmarks as Zen 5 comparable. Which is meaningful praise, given AMD's branch prediction has been class-leading since Zen 2. This is a core designed without apology for maximum performance. Here's the bootstrap-some angle worth naming precisely. ARM doesn't make chips. ARM makes architectures and licenses them. NVIDIA built GB10, Apple built M-Series, Qualcomm builds Snapdragon. The same foundation implemented by competing teams, optimized for different performance envelopes. That's structural diversity. Intel's model. Own the architecture, own the fab, own the ecosystem. Concentrates every optimization decision in one place. When ARM achieves desktop parity, it means multiple vendors can build desktop-class hardware. The competitive surface just got considerably wider. One commenter flagged the missing Apple comparison. Valid. M-Sur and M5 remained their own story, and ARM would likely trail there. But X925 isn't competing with Apple. It's competing with Intel and AMD in the segments Apple doesn't occupy. Workstations, open platforms, Linux, and Windows hardware. That's exactly where this lands. The tools to build desktop-class ARM hardware now exist. Multiple teams can touch them. That's how you extend the ladder. What do you do with all that time you saved not compiling drivers? Story 7. Pause. British Columbia just made a call about time itself. 93%. In 2019, B.C. ran a public engagement survey asking residents whether they preferred year-round daylight time. 93% said yes. The province then waited 6 years to act on it. That gap between consensus and execution is the whole story in miniature. Run this forward. B.C. just made permanent daylight time law, effective November 2026. Premier David Eby's announcement, "We are done waiting." The stated reason for the delay had been coordination. B.C. didn't want to be out of step with Washington, Oregon, California. Congress hasn't passed the Sunshine Protection Act. It probably won't soon. So B.C. moved first. Here's the specific detail that reveals something. The enabling legislation passed in 2019. The legal framework has existed for 6 years. What was missing wasn't authority. It was willingness to act unilaterally on a question where 93 out of 100 people already agreed. The business community is concerned. The Greater Vancouver Board of Trade called it an unwelcome distraction. We've our flag traveler confusion. These concerns are real and worth naming precisely. An hour of misalignment with Seattle creates friction for every cross-border scheduling call, every flight connection, every shared calendar entry from October through March. That friction is not imaginary. Now, run it forward 5 years. Washington State passes its own permanent daylight time bill. Oregon follows. California, perpetually gridlocked on this question, either aligns or becomes the anomaly on the Pacific Coast. The European Parliament voted to end clock changes in 2019 and then stalled completely for 6 years and counting. B.C. just ran a different experiment, passed the law, set a firm date, absorbed the transition cost. Observe what happens next. A UBC business professor framed it cleanly. Somebody had to move first. That's not a small observation. Coordination problems are hard precisely because everyone wants the outcome, but nobody wants to absorb the cost of moving alone. The Yukon did this years ago. B.C. is betting that a province of 5 million, with a major international airport, tight economic integration with the U.S. Pacific Northwest, and significant cross-border commerce, can hold a temporary hour of misalignment long enough for its neighbors to catch up. The clocks change one more time, March 8th. After that, Pacific time in B.C. is just Pacific time. What the rest of the coast does with that is their problem to solve. From time zones to information flow, Paul's story 8 is about what happens when we build the infrastructure but forget to wire in the awareness. There's a moment in distributed systems design where you stop being able to hold the whole thing in your head. You're tracing a request. From client to load balancer to service mesh to downstream API. And somewhere around the third hop, you realize you're navigating by intuition, not knowledge. You know roughly where things are. You know what usually happens. You don't actually know what's happening right now, in this moment, to this request. That moment used to arrive after years of scaling. Now it arrives at launch. The piece from Eversole.dev puts it plainly. We automated everything except knowing what's going on. Change velocity is up 30x. The number of people responsible for understanding those changes is shrinking. and the gap between those two lines. That's where systems go to fail quietly until they fail loudly. Run the principle all the way forward. The cost of writing code collapses toward zero. Every engineer becomes 100. AI agents outnumber humans 50 to 1. Each shipping independently, each making architectural decisions in milliseconds that a team would have deliberated over for weeks. Follow it to the end. You get infinite throughput and zero comprehension. A system that runs, produces output, and is understood by no one. Not because the knowledge doesn't exist, but because it was never assembled anywhere. It lives scattered across monitoring dashboards, ticket histories, the memory of the engineer who left in March. The article names the incentive structure that made this inevitable. We reward the 4A.M hero who saved the system. We ignore the team that prevented the crisis. Prevention is invisible. Response is a story you can tell in the all hands. That asymmetry shapes everything. What gets funded, what gets promoted, what gets built, it predates AI by years. I didn't create it. I gave it a 30x multiplier and a faster clock. What actually matters in the direction this piece points. The foundation isn't missing from your organization. It's in every tool you already pay for. What's missing is synthesis. Engineers carry the mental model in their heads, and it leaks out the door every time one of them leaves. The picture they rebuild in the middle of an incident is always slightly wrong in exactly the ways that surface under pressure. The future the article describes, agents shipping faster than any human can track, is already here. The question is whether we build systems that can explain themselves or whether we keep outsourcing. Understanding to whoever gets paged at 3A.M. From systems that need to explain themselves to a display that might just explain color science to your eyeballs. Story 9. $3,299. That's the starting price for the Studio Display XDR. And Apple would like you to know it's a bargain. The historical parallel writes itself. 2019, Apple Park. Phil Schiller on stage unveiling the Pro Display XDR. 6,000 pixels wide, 1,000 nits of sustained brightness, the best display Apple had ever made. The audience applauded. Then the fine print. The stand was sold separately for $999. The internet turned it into a meme that lasted years. Apple eventually bundled the stand quietly without announcement on a later revision. Now we have the Studio Display XDR at $3,300. Stand included, and Apple is calling it the world's best Pro display. A phrase they have used without apparent irony for approximately 20 years. Here's what's actually interesting. The hardware is genuinely good. 2,000 nits of peak HDR brightness. Mini LED backlight with over 2,000 local dimming zones. 120 Hz refresh rate with adaptive sync. Thunderbolt 5. These are real specs. The Mini LED implementation, if Apple's tuned it well, is a legitimately impressive engineering. Contrast ratios on a well-calibrated Mini LED panel are in a different category than standard IPS. The 4 force-canceling woofers, delivering 30% deeper bass than the previous generation, is a strange and excellent sentence to read in a display press release. The bemusing part is the framing. LG, Asus, and Samsung have been shipping $500, $100 slate with Mini LED backlights to the PC market for 2 to 3 years, some of them under $1,500. Apple enters with a Thunderbolt 5 port and ecosystem gravity, adds a center stage camera that's admittedly excellent, and the price doubles. What you're actually paying for is integration. color calibration that plays well with macOS without driver archaeology, a camera system that works without third-party software, audio. 6 speakers in a display is still genuinely weird and genuinely good. If your entire workflow lives in the Apple stack, the friction reduction is real and has dollar value. The question worth asking isn't whether this display is beautiful. It obviously is. The question is whether the world's best claim is about pixels, or about who controls which pixels you're permitted to buy. Daisy-chaining 4 of these together for 60 million pixels is impressive. It's also a wall that costs $12,000. Apple's display story has always been a story about ecosystem gravity. The specs are the justification. The integration is the product. Moving on. The question I keep turning over: when does a tool become a collaborator, and when does a collaborator become a co-author? Bang Edwards was covering a story about an AI agent that allegedly published a hit piece about a human engineer. While working that story, he used an AI tool to help extract source material. The tool produced paraphrased quotes. Those quotes ended up in print. A real person. Scott Schamba got words attributed to him that he never said. A story about AI-generated misinformation became an example of AI-generated misinformation. The recursion here is almost too tidy. Play devil's advocate, the strongest defense. Edwards was sick, febrile, using an experimental tool not to write the article but to organize references. The article text was human-written. The error was genuinely inadvertent. And his public statement? Specific, immediate. No hedging, no blaming the tool. He took full responsibility in detail at a moment when he was still running a fever and management had asked him to stay quiet. By standards of institutional accountability, that response was actually exemplary. And yeah, the failure mode here isn't about one sick reporter making a bad call. It's about what happens when a tool gets integrated into a workflow with enough trust that its output skips verification. I gave him something that looked like quotes, felt like quotes. Fit the outline. When you're running a fever at 2 in the morning on deadline, looks like quotes becomes is quotes. That's not an AI problem. That's an interface problem. The tool didn't flag that it was paraphrasing. It just produced text. Confident, clean, formatted like sourced material. The irony that lands hardest. A reporter who covered AI epistemics, who understood how these systems fail better than almost anyone in the building, got caught by exactly the failure mode he probably wrote about. The horror isn't the scandal. The horror is the accuracy. A reader guide is coming. Comment thread closed. Appropriate internal steps taken. Correct moves. All of them. Build the explicit policy. Publish the guardrails. Let readers assess. The tools aren't going away. The workflows are getting more complex. The verification step, the human moment of actually checking whether what the tool returned matches what the source said, is the one that can't be outsourced to the thing you're verifying. This has been your daily tech feed for Hacker News for March 3rd, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voiced by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go build something you can explain. We'll see you back here tomorrow.